Hey y'all, my name is Nem and welcome to my Lab 1 for Physics 2, which is all about charge, tape, and Coulomb's law. Alrighty, so the purpose of this experiment will be to observe how pieces of tape interact with each other when loss of electrons affect their overall net charge, and also about how these charged species react when they're contacted with neutral species, such as my hands. And a brief overview of the results is that all of my experimental values actually matched up with the predicted values, despite the potential errors that could have happened that we'll talk about later. And the electrons lost that I calculated was 8.44 times 10 to the 26. Alrighty, and then for the physics principles and science background, first we have Coulomb's law, which is an inverse square law, and this is used to calculate the amount of charge on one object to another. Also, we will use the gravitational force, which is another force which normally contradicts the Coulomb's law, and this gravitational force is in the negative direction, mg, as many of you know, and then the electric field, which calculates how much electricity is forming around the electron clouds around an object, which is not only affected by an electron's negative charge, but also with the inductive forces of those electrons. So similar to how I just said, in my free body diagram, this red dot is going to be my tape. The tape dimensions between the two pieces of tape, there's about almost 3 centimeters. The tape length was 22 centimeters, the width was 2 centimeters, and the mass was very, very small in kilograms. And basically, the electric force was pushing it up, while the force of gravity was pushing down. Then I also did some calculations. So for the force of gravity, it was 2.17 times 10 to the negative third. And then Coulomb's law force was also the exact same number, which is how I know that they oppose each other. And then the overall charge was 1.35 e to the negative 8. And then for the number of electrons lost, it's the charge of the tape, which I just said was 1.35, divided by the charge of an electron, which is a constant. And that ended up being about 8.44 times 10 to the 10th, which is a lot of electrons lost from the tape. Okay, and then for the code, it was pretty simple from the code that was given to us. First at the top, we have all of our constants, which I listed before, and you can look through the previous slides if you'd like. And then we applied the earlier equations, which I talked about for Coulomb's law, the force of gravity, and also the electric field. And then I used the print function, so that way when we got the results of the tape and electrons, that the calculations will be stated numerically. And then also for the picture, literally in the results category, that was all done at the bottom to make sure that the objects were the right colors, clearly labeled, and also that they had the correct magnitudes of force. Like I just said with the code, the orange is going to be the electric force and the green is going to be the gravitational force, which had the exact same magnitude, so they directly oppose each other. And in the bottom left, we have the charge of the piece of tape and also how many electrons are lost from each piece of tape. So the electrons lost experimental and also lost predicted are the exact same at 8.44 times 10 to the 10th. And then the charge experimental and predicted is also the same at 1.35 times 10 to the negative 8. And there are 8.44 times 10 to the 26 electrons lost. And the calculations for experimental and predicted are the same, but they're probably slightly different if you go out more significant figures because of the errors that I'll discuss later. And the Q is positive because both pieces of tape become charged positively after losing all those electrons, because 8.44 times 10 to the 26 is huge. And because two positively charged objects repel one another, tape A is always going to move upwards away from tape B, as it did in my experiment. And just as I talked about the tapes repelling, so the what ifs, if they had been positive instead of negative, for the electrons, if they're both positive, they'll always repel. As they are both negative, they'll always repel. And then some of the errors in the calculations were that I only calculated for electric force and also for gravitational force, but there were no other air resistance or drags taken into place. We also assumed both pieces of tape had the exact same charges, and that the piece of tape, it was actually a lot larger than one single point, so the amount of electron cloud would have been much larger than assumed, and also charges could have been lost from things such as my hand holding the tape or the table or etc. Thank you for watching.